So finally, just to conclude this lecture, you'll remember that every lecture concludes with some questions. So I'll just address some of these questions. I'll not do them all. You can assume that if I'm speaking about these questions now, they're relevant maybe to future assessment or certainly relevant to the exam. So question number 1 is pretty important. What problem arises if machine instructions of a specific process only reference physical addresses? Well, the key problem, of course, is that physical addresses may belong to another process or to the kernel, and it's just a violation of security and privacy. A system that only uses physical addresses also commits then to reserving portions of memory for specific processes, and that simply won't work in a multitasking system. The next question, what is a logical or virtual address? And the question that follows on from that, what is a physical address? They're pretty, I think, obvious. Logical addresses or virtual addresses are private to the executing process. They have to, they represent the addresses used by the machine code instructions, but they are entirely within the private bubble of delusion that processes operate in. So a physical address is just an address in the actual hardware of the main memory, in the RAM of the system. So the purpose then of the memory management unit is that it converts physical addresses into, converts logical addresses into physical addresses. And the benefit of doing that is that by separating the logical address space of a process from its physical address space, you're then allowing it to be loaded into any available space in main memory, and the problem then that the hardware has to sort out is how to convert the logical addresses into the correct physical address. Other benefits arise in regard of not having to use contiguous allocation. So contiguous allocation is very, very problematic because of the memory needs of processes which are growing and shrinking continuously. It simply doesn't work. We then have a question about external fragmentation. Well, external fragmentation is very wasteful of main memory because you may have portions of main memory which are entirely separate from each other, which when they're aggregated together may be enough to satisfy memory requirements, but by themselves are of no use to processes which are bigger than any individual chunk. You can see that we've got a few of the overarching goals. So protection, I think, is particularly important, and isolation is a kind of consequence of protection. Transparency relates to the whole business of managing processes in a multitasking system. It should be clear from the content of this lecture that processes really don't have any idea what's going on in terms of lower level management of their memory requirements, and we'll certainly see that in terms of the discussion that we'll have in the next lecture, which is about virtual memory. Relocation is just the idea that a logical address can be mapped to any physical address. Okay, so there's no beforehand reservation of addresses for a particular process. Any process executing at any time gets whatever address, whatever physical address is available to it. Question 12, give a detailed explanation of paging as a memory management technique. The more astute of you will have realised that this is the type of question that you get asked on in the exam. You should certainly review the exam paper from last year, which you'll find in the library. And then the last question, which is how are the higher level goals of memory management realised by the paging mechanism? Well, paging gives you relocatability, gives you isolation, it gives you security and protection. But this last question is probably not something that I would ask, but it should be implicit in your understanding of the paging mechanism.